Finally, JPEG is by far the most common image format because it's old, well understood, and royalty-free. There are some additional notes and major shortcomings to the JPEG algorithm that we should discuss. First, sometimes you can select how much you want to compress an image, and this scaling level of compression changes the values in the quantization table. Because the algorithm divides using these quantization tables and then rounds to the nearest result, if we increase the values in the table, we will inevitably get more zeros in the resulting discrete cosine transformed and quantized block, and as a result the file will be smaller. However, with too much compression, you get artifacts, or issues with the compressed image that look like blurry splotches on the edges of square blocks. The next note is that earlier we mentioned that quantization removes high-frequency data, which is partially correct. In reality, quantization reduces the precision of an image block and reduces the precision more for the high-frequency data compared to the low-frequency data, thus making the image block less accurate. The third note is that JPEG is great at compressing pictures taken from a camera because natural world pictures tend to have a lot of smooth textures, and because no camera is perfectly in focus, it's hard to tell the difference between the uncompressed and compressed image. However, it doesn't perform well at compressing vector graphics like this. And in fact, you get rather noticeable artifacts close to the boundary lines in vector graphics. This is because the JPEG algorithm needs to reconstruct these straight lines using the base images, which don't work perfectly when the data is compressed. Therefore, it's recommended not to compress vector graphics using the JPEG algorithm. Finally, JPEG is by far the most common image format because it's old, well understood, and royalty-free. But there are a number of other image formats, some with comparably better compression capabilities.